In this video, I'm just going to show you how you find the inverse of a matrix by using something called an adjugate of a matrix. Then the relationship between A inverse and an adjugate will be given by this formula like this. So let's first say like we have a matrix A, and then that matrix it's 1, 2, 3, 1. Well, let's just say minus 2 here, so we can make the determinant to be positive. And let's say we have 5 like this. So let's say we have 5 minus 2, 3 minus 1. So if we were to find the determinant of that matrix, 5 minus 2, 3 minus 1, it's basically going to be equals to minus 5 plus 6, which just gives us 1 for simplicity reasons. And then in something called an adjugate A, first we have to find a cofactor matrix obtained from A. So if we look at the matrix here, if we look at 5 here, that basically means that we're going to be excluding this row, and this column here. So you'll just have to remain with minus 1. And another thing you need to keep in mind is the signs of a matrix. Plus, minus, plus, minus, plus, minus, proceeding like that. So now a 2 by 2 matrix will be obtained from here. And then this basically means that the first entry here, you'll just keep it as it is. And now when you look at minus 2 here, you exclude this column and this row, then you just remain with 3. And that 3 here, you're gonna basically have to change the sign of that, since it's just gonna be minus 3 here. And you do a similar process here with 3 as well. And you can, so when you look at 3 here, then you're basically gonna exclude this column and this row, then you just remain with minus 2. And this just tells you have to change the sign of that, then you just have positive 2. And then another thing you need to keep in mind is the last entry here, then you exclude this column and this row, then you just remain with 5, and you just keep the sign as it is, then you just have 5 like this. And now an adjugate of a matrix here will be given by something called a transpose of a matrix. So it will just be B transpose. So that means just swap the rows and columns of B. And then when you do that, then you're just gonna have 5 here, and you're gonna have minus 1 here. Oh, sorry. It's reflection along the main diagonal. So this will just be the diagonal will stay the same. This row will become the column, which is just minus 1 and minus 3, and this row will become the second column, which is just gonna be 2, 5. And then that's an adjoint or an adjugate of a matrix. And then that means that A inverse will be given by something, the relationship that I showed, 1 over the determinant multiplied by an adjoint of a matrix. And then from here, you're just gonna have our determinant that's 1, and then an adjoint or an adjugate of that will just be 1, minus 1, 2, minus 3, 5, and then 1 over 1 it's 1, and you distribute it inside, then you're just going to end up with something like this, minus 1, minus 3, 2, 5, and that will be your inverse of a matrix. So this is a cofactor matrix, and then you transpose it to find an adjugate of a matrix. So let's check this process on a 3 by 3 matrix. Let's say that we have our matrix 1, 2, 5, 0, 3, 0, 3, 0, 3, 1, 0, 0, 1, like this. So let's call this our matrix A. So the first thing we have to do is find the determinant of that. So since this matrix is already in row echelon form, the determinant will just be the multiplication of the diagonal here, 1, 3, 1, then it's just going to be 3. And then now we need to find the cofactor matrix of that. Now the cofactor matrix of that, let's look at this. Now we look at 1, then we exclude this, and then we evaluate the determinant here. It's just going to be 3. And let's just keep the signs in mind. Plus, minus, plus, minus, plus, minus, plus, minus, plus. And then for the first entry, obviously, the sign should stay the same. And now when we go to 2 here, we exclude this column and this row, then the determinant is just going to basically be 0. And then you look at number 5 here, then you basically exclude this, and the determinant will be 0 as well. And then you look at 0 here, you exclude this and this, you exclude this and this, then your determinant is just going to be 2, and then you have to switch the sign of that, then it's minus 2. And then you look at 3 here, you exclude this ones, and then you're just going to have your determinant to be 1, and the sign stays the same. And you look at 1 here, you exclude this and this, and then you're just going to have 0. And then for this one, you exclude this and this, then you're just going to have 2 minus 5, 2 minus 15, that's going to be minus 13, and the sign stays the same. Then you have minus 13. And then for this one, you exclude this, and then you're just going to have your determinant being 1 there, and you're going to have to change the sign, then you have minus 1. And for this one, you exclude this and this, then you're just basically going to have 3, and the sign stays the same. And then now an adjugate of that matrix will basically be B transposed. And when you transpose that matrix, it's a reflection along the main diagonal, so this row becomes the first column, 3, 0, 0, and the second row becomes the second column, which is just going to be minus 2, 1, 0, and the third row becomes the third column, minus 13, minus 1, and 3, like that. And then what you're gonna do next is you're gonna have to use the formula, and then A inverse will be equals to 1 over the determinant multiplied by an adjoint or an adjugate of that matrix. So then our determinant, to evaluate it to be 3, and an adjugate of that matrix is basically this one: 3 minus 2 minus 13, 0, 1, minus 1, and then you have 0, 0, 3. And then what you're gonna do is like distribute 1/3 inside. So your A inverse will just basically be 1 minus 2/3 minus 13/3, and then you're gonna have 0, 1/3, minus 1/3, 0, 0, and 1. So that will be your A inverse using the cofactor matrix. So this is all about like finding the inverses using the cofactor matrix, transposing that to find an adjugate matrix, and then this is how you'll do it.